Welcome back to Advent of Code. Possibly the last one of 2015. We've got 22, 23, 24, 25 to do. And 25 is probably just a part one, so see if we can do this. So Alright, are we ready? Let's begin. 22. Okay, it's taking a long time to load. Okay. Wizard Simulator. Ooh, this looks similar to the previous one. It's more RPG mechanics. Probably reuse code as well. Let me just plug in my stuff. Right. Little Henry Case decides that defeating bosses with swords and stuff is boring. Now he's playing the game with a wizard. Of course, he gets stuck on another boss and needs your help again. In this version, combat still proceeds with the player, and the boss taking alternating turns. The player still goes first. Now, however, you don't get any equipment. Instead, you must choose one of your spells to cast. The first character at or below 0 hit points loses. Since you're a wizard, you don't get to wear armor. Can we cast mage armor? And you can't attack normally. However, since you do magic damage, your opponent's armor is ignored, and so the boss effectively has 0 armor as well. As before, if armor from a spell in this case would reduce damage below 1, it becomes 1 instead, okay. On each of your turns, you must select one of your spells to cast. If you cannot afford to cast any spell, you lose. Spells cost mana. You have 500 mana. Your spells are Magic Missile, Drain, Shield, Poison, and Recharge. Oh man. Effects all work the same way. Effects apply at the start of both the player's turns and the boss turns. Effects are created with a timer. At the start of each turn, after they apply any effect they have, their timer is decreased by 1. If this decreases the timer to 0, the effect ends. You cannot cast a spell that would start an effect which is already active. However, effects can be started on the same turn they end. For example, suppose the player has 10 hit points. Okay, let's have a look at the spells. Magic Missile costs 53 mana. It instantly does 4 damage. Drain, 73 mana. Does 2 damage and heals you for 2 hit points. Shield, 113 mana. It starts an effect that lasts for 6 turns. While it is active, your armor is increased by 7. Poison costs 173 mana. Starts an effect that lasts for 6 turns. At the start of each turn, while it is active, it deals the boss 3 damage. So, over 6 turns, it is I mean, that is much more effective than Magic Missile. Well, to the point you almost probably never want to do Magic Missile unless you're just killing them in the final turn or something. Because that's... Not only is that so much less mana per turn, but it frees up 5 turns for you, essentially, and you're doing a lot more damage. Okay, Poison is pretty good. Recharge. Like, you would never really want to use Magic Missile unless you're just out of mana on the final turn. Recharge. Costs 229 mana. It starts an effect that lasts for 5 turns. At the start of each turn while it is active, it gives you 101 new mana. The only way to get more mana. So if you're under 230 mana, then you kind of need to do that, don't you? Otherwise you're going to run out of mana unless you think you can beat them. Interesting. Alright, suppose the player has 10 hit points and 250 mana. And the boss has 13 hit points and 8 damage. Player casts Poison. So Poison, the timer is 6. But nothing happens on that turn. Okay, then the boss's turn. Okay, so that you deal the poison and then you reduce the timer. And then the boss attacks. Then we cast Magic Missile. Oh yeah, because you can't cast poison when you already have poison active, so that's the use of Magic Missile, doing a bit more damage. Alright, so yeah, that works. Now suppose the same initial conditions except the boss has 14 hit points instead. So we recharge. And we cast shield to increase our armor. Oh yeah, recharge does 101 each turn. I see. So you'd get 505 altogether, minus the 229 you spent. This is pretty complex. You start with 50 hit points and 500 mana points. And the boss has that. What is the least amount of mana you can spend and still win the fight? Interesting. So if you do nothing, you can't do nothing. But if you did do nothing, well, if you just cast recharge over and over again, well, you can't even do that. Let's pretend there was a way to do nothing. Then the boss would do 8 damage each turn. So after 7 turns, you'd die. And the only way to prolong that is to use Drain to heal a bit, or Shield to increase your armor by 7. So probably wouldn't use recursion here. It's like a search. Given a state, which is our hit points and mana points and their hit points, what is the least amount of mana to spend to get to a winning condition, i.e. the boss is dead? And the neighbors we can define by basically which moves we do. And yeah, mana is the distance. Interesting. And we want to use Dijkstra's algorithm, don't we? Or even A-star, but I'm not sure what you'd use for a heuristic for A-star. I think A-star heuristic could be the poison. Because you have to do damage to him, and the cheapest way to do damage to him is use poison. So essentially, you have to spend so 73 mana for 2 damage. Magic Missiles 53 for 4 damage. Poison is 173 for essentially 18 damage. So poison is the cheapest. So that gives us heuristic. Yeah, we could actually do A-star. Because you have to spend at least 173 divided by 6 mana per damage you do to him. There's no other way to avoid that, is there? No matter what else you do, he can't shield. Yeah. So every one of his points of HP costs at least that amount of mana to take down. That's a good observation. That'll help us. Alright, so let's start coding then. I don't think we really need to reuse code here. This is less of a brute force problem, more of a search. I think the search is easier to actually code than brute force in this case. Brute force, you'd have to make sequences of moves, but technically they're infinite. But you'd have to cut off as soon as you've spent too much mana. So basically, the brute force is kind of like search in the first place, so might as well just program search. All right. Oh, hang on. Zoom in a bit. Okay. We don't need any input, so we've got so let's define a state. A class called state, and that describes all the parameters that we've got here. Oh, this would be a good chance to use the static. What is it? Let me look this up. There's a class in Python. There's something introduced to Python which is good for this. Static class? Not static. No, not static class. Python. What was it? Oh, I might have to look up my code in coding game. Alright, let me bring up coding game. Damn it. Alright, I have to log back in and let's do this. To change it to English too. Oh my god, I hate what Google has become now. Now you have to press yes on your phone to verify that you're logging in. Remember when you could just log into Google easily? Confirm whether this is you. Yes, it's me. Okay. Disconnect my Google account from coding game and just make a generic login just to avoid that. All right. On coding game we have, okay, might as well just change the screen here. Okay. Oh, Winter Challenge. When does that start? Soon. Alright, I'll probably stream that too. Alright, but anyway, the last event I had was the Fall Challenge 2022. I thought I used it here. Here, no, not this one. Oh, damn it. What was it? Have a look at the starter code. Where did I see it? It was somewhere here. There we are, data class. This is what I want. This is cool. You can just do this. Define it like this. Alright. So we want basically like this. So, alright, so we've got my HP int enemy HP int my, all right, let's group my stuff and then their stuff. So my armor int my mana int yeah, it's just health, armor, mana. And now we have to have effects. Well, let's put the boss's stuff. So the boss has HP, okay, and now we do the statuses. So basically you just have to define it by a timer, what timer the spell has. Also, a state, it's always our turn. It's the point at which they've done their turn, it's now your turn. So shield poison timer and recharge timer. Is there anything else we need to know? So state is basically just all the properties and it's your turn and no one's died yet. Otherwise that would be a winning losing state. That can be handled separately. Yeah. Okay, so start state. Is this how it works? Let me test this. So you just define the parameters. Data class. Oops, okay. You need all 7 of them, okay. My HP equals 0. Wait, it's 50. Wait, what? You start with 50 hit points and 500 mana points, okay. My armor equals 0. My mana equals 500. Enemy HP equals 55. Enemy attack. You know what? We don't need attack as a property. That never changes, does it? There's no point defining it in the state. And for that matter, I don't know, HP does change, but yeah, don't define attack. That's the starting state. Does that work? Nice. What happens if we print start state? I've never really used data class. This is my first time using it. Nice, look at that. It just prints it all out. I bet, can you put it in a hash table? If you can. That's one of the main things I need. Unhashable. We still need to define hash. It makes sense that you would still... Oh, it's self dot. Damn it. Hang on. All right. Okay, it works. All right, fine. All right, so we're going to define A star let's copy what we did before. Was it 19? Yeah, copy the A-star algorithm here. Modify it. So we don't have a goal. Heuristic. We would do state.enemy HP times so it was it'd be 173 divided by 6. That's effectively a estimate for how long it would take to kill them. At least that amount. Alright, so Q. Priority queue, import that. Okay. Distance. Start is 0. Why not queue empty? Get the current. Okay, so the goal check. We don't do it here. Well, we should do it here. Yeah, we do it here. So we are allowing the enemy to have negative or 0 HP. Let's say 0. So if current.enemy HP or yeah, okay. Hello, Mara. Is 22 hard? Not hard. It's basically a more complex version of the weapons and armor thing. Let me show you the... I'll put the link as well. So we're using a wizard instead of someone with a sword. So it is more complex. And it's not as feasible to brute force it. Hang on. But basically, instead of buying weapons and stuff, you can cast spells. And the spells are complex because they have lasting effects that last for several turns. So you could cast poison so that the enemy would lose a bit of HP every turn for 6 turns. Or recharge to get more mana back. And the goal is to kill the enemy using the least amount of mana possible. So it's not even how fewest number of turns. So we have to use some sort of Dijkstra A-star algorithm here instead of... Even breadth first won't work because we need least amount of mana rather than least amount of turns. Yeah, and the spells, yeah, they're quite complex as well. So there's like 5 different spells. 2 of them are instant, and 3 of them create lasting effects that you have to track. So they have timers on them. But if I code all this in, I guess it's just a case of doing A star or whatever and seeing. So I'm now on the A star bit. Just trying to put together the. I have this state which describes all the parameters: my HP, my armor, my mana, enemy HP, and the timers for the shield, poison, and recharge. So if there's 0, that means they're not active. And if they're higher than 0, that means they have a timer. We start with 50 HP, no armor, mana. You know what? We don't need armor, because the shield timer is effectively telling us if we have armor or not. If it's 0... Let me have a look at how this works. Yeah, shield timer tells you what your armor is. So we don't need to have armor. If shield timer is above 0, then you have armor, otherwise you don't. Okay, that's one fewer thing to track. Okay. So, how do we check if... Okay, so if enemy HP is 0... that means we've won. We're not, even if we're dead, that means we killed the enemy before... Well... There should be no state in which we die, because we're not going to let the enemy do their turn. If, we kill them. Okay, so... I would have done something like this for the physical damage one, so it would have been easy to adapt. But the physical damage one, there were no choices at each turn. You have to attack and defend and attack. You just have to attack each turn, don't you? So there's no branching. You only make one choice, and that's at the beginning. What to buy. And then from then on, it's all decided. So I don't think you could really do a search, because there's nowhere to search. It's just one line. You don't have to make choices at any step. So it's just choosing your starting point, of which there are many starting points. But there's no notion of neighbors or moving from node to node. So yeah, I also can't really reuse any of my code from that one. It's fundamentally different. So yeah, so if the enemy HP is 0, that means we've killed them and we return the we found the least mana path. Dist is recording the mana used. Alright, get neighbors. This might be a bit lengthy, so we have to check all the possible neighbor states we can get to. Actually, okay, we just got to go through each spell, basically, and decide if we can cast it Wait, is there ever a... Is there ever... Okay, let's have a look. If it's technically possible to basically softlock, well, it didn't say you have to cast... Well, you do have to cast a spell every turn, I think, but... Well, you probably don't. But is there ever a reason not to... Oh, no, yeah, you may want to wait while your mana is recharging, in which case you would want to not cast any spell. So I guess I should allow a state where you do nothing. But I won't allow it if you don't have recharge active, otherwise you're not actually gaining anything. Or poison as well. So if you have poison or recharge active, then I will say doing nothing is a valid move. If you don't have either of them active, then doing nothing achieves nothing. So I won't allow it as a move you can do. Otherwise, it will just increase the branching factor. Yeah. So... we need a copy method for the state. Oh, I think that's built in. I should be able to just do that. Let's try this. T equals start state.copy. No, you don't do it like that. You do copy. Copy constructor. T.hp, let's change the HP to be 1000. Print, make sure we don't alter the original state, and check the new state. If this works as I expect it to, then we can just use that. Nice! It has built-in copy constructor for this data class thing. This is new. They recently added this to Python. Well, when I say recent, maybe in the last few years, I don't know. But this means you don't have to keep writing that. I was always writing, the initialization constructor. So set my HP equals self.myHP equals my HP, self.my mana equals mana every time someone creates a state. Python 3? Yeah, it's Python 3. And then having to define, okay, hash you still have to define because that's non-trivial, but you don't have to define copy, you don't have to define print. So I always had to define what it is to print, and I had to say put my HP, my mana, enemy, blah 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 in one string. It does that automatically, so I can just print start state. Probably other things you can do out of the box as well. Yeah, it's great. It saves me so much time. Alright, so we know how to do that. Okay, undo all that. So we never alter state. We create a new state. Equals a copy of state. Now, before we decide on which spells to do, we have to first execute the spells that are active. That happens first. So, I've been using this is not really the Python way of writing variables. I'll leave that. By armor equals 7. No, yeah, 7 if use state dot shield timer else 0. So we extract our armor from that. If use state dot shield timer new state dot shield timer minus equal 1. Alright, that deals with the shield. If new state dot poison timer we want to you do poison on the enemy. Poison does 3 damage. New state dot enemy HP equal minus equal 3. New state dot poison timer minus equal 1. He might die, so we should check for that. We don't really want the enemy to do his turn. If you state dot mana timer, no, it's recharge. New state dot mana my mana we recharge by 101. So that handles all the spells. And now we're ready to do our turn. At this point, the enemy might be dead. So, just say if new state dot enemy HP equals, let's say max 0. Just yield that new state then. And return. Don't bother finding any other neighbors. That's the only neighbor we go to. Get neighbors. Oh, we have to return the distance as well. So we spend 0 mana because we didn't do anything. And we arrive at this new state. Excuse me. So now we have to check all the possible choices we can make and what neighbors they lead to. Do nothing. So if new state dot poison timer or new state dot recharge timer, those are the only, if those timers are active, it's feasible to do nothing. Otherwise, there's literally nothing we can gain out of doing nothing, as far as I can tell. Yeah. So we do nothing, but the enemy still does their turn. So, enemy do nothing state dot my HP. How much damage do we take? It's enemy attack is 8, isn't it? Yeah. 8 minus armor. They said you still have to account for, or they said if you do less than 1 damage, you still do 1 damage, but that I can't see that actually happening with these conditions they've given us. So So that is redundant. We don't need to make that check. Hang on. So no matter what we do, well, unless we kill them, but yeah, okay, that's right. Okay, so yield 0, do nothing state. Okay, so that's the do nothing. Alright, what other choices do we have? Basically, we can choose between the remaining spells. Magic Missile. If new state dot my mana is greater or equal to 53, we can cast Magic Missile. It instantly does 4 damage. So enemy HP take away 4. And if they're still alive, then we take damage too. And now we yield. We spent 53 mana, and this is where we arrived at. Okay. Okay, what else? Magic Missile. So, Drain is similar. It's instant. So if we have at least 73... Oh! We need to reduce our mana. Don't forget that. So this one is called Drain State. So Drain State dot my mana, spend 73. Enemy HP loses 2. We heal. Now, I don't think we have a max HP, do we? Did it say anything about that? Heals you for 2. No. So we can, in theory, just increase our HP infinitely. Alright. Which you can do, because you can cast armor, he'll do 1 damage, and then you can heal by 1 HP extra. No, wait. Drain heals us for 2. But he'd die eventually, but yeah. Plus equal 2. So we spend the mana. He takes the damage. We heal 2. And if he's still alive, we take the damage. And we yield 73 and the new drain state. Okay, so far so good. Now we can cast Shield. If new state dot my mana is greater or equal to 113. This takes a long time to code, doesn't it? Might be one of the longest yet. We've just passed 1 hour. Alright. I haven't even run anything. Wait, shield state dot my mana minus equal 113. So the only thing shield state does is set the timer to 6. But the effect is instant, so our armor is now 7 no matter what. Wait, oh, there's something we need to check. If new state and... So you're not allowed to cast it if it's already active. And that's important because you could kind of boost the timer on your armor, your spells if you were to recast it. So if we have the mana and new state dot shield timer and we don't have time on our shield timer. So if we cast it, then shield state dot shield timer equals 6. Oh, I think it says, okay, effects can be started on the same turn they end. I think if we cast shield now, it won't be active until next turn. Let's see. I think there's even an example. Okay, player casts shield, increasing armor by 7. Boss turn. Oh. These spells activate on the enemy turn too, so this is more complex. I have to rewrite some of this. So on my turn, recharge activates, and on the enemy's turn, recharge activates too. But we can just assume... We can just assume it activates twice at the beginning of our turn, because it doesn't actually matter that it happens on their turn. The end result is either that shield continues to activate. Oh, it does matter for shield, doesn't it? But the thing is, if you cast shield, then on their turn, it'll drop to 5. Then on mine, it'll drop to 4. Then on theirs, it'll drop to 3. Mine, 2. Theirs, 1. Mine, it'll drop to 0. Interesting. Okay, I'll have to adjust this, but it's not too bad. So, okay. So, alright, so my armor is 7, that stays the same. If we have a shield timer, subtract 2 instead of 1. That accounts for the shield timer on the enemy's turn. And that is what's still protecting us. And there can never be a situation where shield is on our turn but not on theirs, because shield is an even number of... it has an even timer. So when you put shield on, it activates for an even number of turns, which means if it's ever active on my turn, it will also be active on their turn too. So that's safe. It'd be kind of weird otherwise. Poison timer. This one... See, there's two ways I could... Poison timer... is also 6 turns. So activate on their turn too. So I could say... we just activate it twice. Now, the thing is, that's a problem because they could kill us before the second time. No, could they? No, poison activates at the start of their turn, so they never have a chance to kill us. So that's safe. Okay, so we just apply damage to them twice. Okay. And recharge timer. This one... we need to handle one step at a time because we might not have the mana on the boss's turn. I can't just give myself 202, because that will let us do spells that we couldn't actually do until the boss's turn. So we'll sort that out manually. Interesting. Oh no, there's another issue here. Alright, you know what? Let's stop cutting corners. Let's just do everything completely step by step, because if we set this to 0, that will let us cast shield again when we're not supposed to be able to, because it's still not 0. Okay. Backtrack. Put this all back to where it was. Alright, so we do one thing at a time. My armor is 7. Yep, that's correct. New state. Okay, so decrease the HP, the timers. Okay. If the enemy is dead at this point, then we yield the state. That's fine. Right, now we choose our turns. Do nothing. So again, unless there's a poison timer or recharge timer active, there's no reason we would do this. Okay, so we just have to do all these steps again. So first, I should actually make a method here for this. So that, because there's repetition here. We want to handle what happens on the enemy's turn. So define enemy turn of a given state. We just want to get back what the next state is, and that's decided. We don't have any choices here. Alright, so we have to do all these steps again. So at the start of the enemy's turn, we do all this again. My armor is 7. If we have shield timer L0, then we reduce the shield timer. That's correct. Also, we don't need to set it here because it's not used on our turn. So shield doesn't do anything on our turn. Poison does do stuff on our turn. Recharge does do stuff on our turn. Okay. Right. We set the timer to... We reduce the shield timer. Alright, poison timer. We handle the poison. That's correct. Recharge timer. We add our mana. Okay. So oh, we shouldn't be modifying the state here. Yeah, this is taking ages. Well, we're almost there. Okay, enemy turn state. So we extract our armor, handle the timers. If the enemy's still alive, then the enemy does his damage. So enemy turn state dot my HP subtract 8 minus my armor. And then we just return this, right? Okay, so that's decided. Okay, so we've got a method for the enemy's turn. Alright, so do nothing. Alright, let's go back to all this stuff. So the do nothing state is where we copy the new state. No, we just do enemy turn of new state and yield that. And this one handles that. Okay. Magic missile. If we have the mana, subtract our mana, subtract enemy HP. Probably should if enemy turn state dot enemy HP is 0, just immediately return. Okay, so magic missile. Handle the mana, we handle the enemy HP. And then we yield 53 and enemy turn of magic missile state. Okay. Drain. Create the drain state, reduce the mana, reduce the enemy HP, add our HP, and then do enemy turn off drain state. So far so good. Shield. If so shield timer must be 0, and we must have the mana. So create the shield state, create the mana, set the timer to 6, and then we yield 113 enemy turn. So enemy will basically do their turn with our shield state being 6, and it will reduce to 5 on their turn, which is in line with the example. Alright, and now finally recharge. No, poison next. Hang on. so if they have... No, if we have at least 173 and we don't have a poison timer, then poison state. We would remove 173. Poison timer is 6 as well. Okay. Is that it? And then on their turn, they'll subtract the damage. Yeah. Okay. And then recharge. Okay, so new state dot my mana is at least 229. So the timer will be 5. Okay. So, oh, this is part 1 as well. What's part 2 gonna have? It might just be a nice change from this one, I don't know. Alright, so recharge state, we take the mana, set the timer. Nothing actually happens on our turn. It will happen next turn, on their turn. And then we yield the enemy turn. Okay, I've set all the spells. That is the whole of get neighbors. It's probably the longest method I've written so far. Okay, so that's get neighbors. So for neighbor and get neighbors of coding the unbeatable AI. So for each for cost neighbor state in get neighbors. Tentative distance equals distance to current plus the cost we spent here. If neighbor state is not known yet, or the tentative distance is less than what we already know, then we update the distance to be the new distance. And q.put the neighbor state into the queue. Yeah. And then so ultimately we just print a star, the start state. It's not going to tell us the path we took. We can configure this to tell us. Let's see if we actually get an answer though. All right, 22. Error. Oh, hang on. Q.get. Less than so it doesn't know how to tie break. Because we've put in a state to the queue, the priority queue. We only care about the integer value being used for the priority determination. But because of the way priority queue works, they also tried to compare the node itself. We just want... Is there a way around this? Okay, we always have to... I always have to do this, but I... Can you... Q.put... Let me have a look at put. Is there documentation for this? Okay. Because what I would like is to put data, which is not orderable, and have the priority separately. But instead, what I'm having to do is put a tuple in where the data is the second parameter in the tuple. I don't actually want it to compare the data because data is meaningless. Now, let me look this up. Python priority queue. And I don't really want to have to define less than on my data because it doesn't make sense. So yeah, according to some documentation, a typical pattern for entries is a tuple of the form priority number, data. If the data elements are not comparable, the data can be wrapped in a class that ignores the data item and only compares the priority number. Fine, but I don't want to have to do that. Okay, actually, we could try this. This is interesting, actually. This is probably what I should do. So you do this. Hang on, wait, not there. It's part of A star, so put it here. Data class, order equals true, class, prioritized item. Priority is an int. Item is any. So instead of putting so Q is priority Q, Q.put. So instead of this, instead of putting in a tuple like this, we can do this is a smarter way of doing it. Q.put prioritized item. Priority equals H start. Item equals start. There. Now it stops trying to compare items and it purely uses the priority. I'm going to do that from now on, whenever I use priority queues. So later on when we put state in, we do neighbor state. Okay. And to extract, we need to do This is even better. Current equals q dot get dot item. We don't even have to discard the priority value. All right, try that. Field? What's field? Import field. Import typing.any. Okay, interesting. 971. If that's the answer, then great. Otherwise, it's going to be a pain to debug this. Like, there's so much. Even a slight arithmetic error somewhere could have. 971. I mean, even if I made an arithmetic error, we might still get it by chance if we happen to not do that spell, or it wasn't, that order didn't matter. Not the right answer, too high. Okay. Now I have to check, like, everything. We can, okay, try setting H to 0. Because that's also technically valid too. See if we still get the same answer. What? Oh yeah, no, I know what the problem is. We haven't done this correctly. You don't put it in with H, priority H. You put it in with priority dist plus H. Whoops. So it's doing something really weird that's completely invalid. Okay, do that. 97, still 971. But that what I was doing was so wrong. Oh, and the very first item is also wrong, but would that matter? No, that's right. The first item is correct, yeah. H, you use the H there. How is it still 971? Priority. Hang on, I gotta look this up online. A star. Check the pseudocode again. So, priority queue, you choose the lowest F score. An F score is the tentative distance plus the H. Now I was using just the H, and I was getting 971. Now I've put in the distance and the H, and I'm still getting 971, so something is horribly wrong here. How many things are we actually getting from our queue? Print. Current. Let's see what they look like. That many states. Oh, we're not handling what happens when we have negative health. Ah, we didn't handle dying. Actually losing. See, this case, the enemy has HP. We don't. That should be a loss. How do we handle that? So we shouldn't put that in the queue. No. That's a valid neighbor. This method is called get neighbors. It doesn't care whether you're dead or alive. That's still a neighbor. That's still a state. Okay, so we still yield it. But we have to have a look at that now and say, if neighbor state dot IHP is less than 0 and neighbor state dot enemy HP is greater than 0. Because if they're both less than 0, that means we kind of killed each other. We killed them and then they killed us, but that's kind of the same as we killing them and nothing happening. I'm just kind of taking a shortcut there. So if... just skip that one. So if... oh, less than or equal to 0. Continue. Nine, 8, 7? Not much different. Interesting bunch of states. See, we're not often using recharge. I think it's because it's prioritizing the ones where you're hurting the enemy early on. But we are sometimes using recharge. But 987 is higher. What? That's worse. It's more correct though, but it's worse. It's further off. But we fixed a bug at least. Yeah, but I feel like recharge should be coming up more often because so recharge, I don't know. Okay, so we got 987. What if we've set H to 0? It should still be 987. H is just making it run faster. (914) Our H. Because technically you can kill the enemy without doing anything. So this H is not helping us because we're saying at the very minimum you have to spend this much mana to hurt him. But you might have already put poison on him, in which case you now spend 0 mana per turn to harm him. So there's no sensible H to account for that, because you can always spend 0. Okay, so you know what? We don't need H. Okay. 914, they're claiming. 914? Let's try it then. Too low. It's between 914 and 997 or something. Wait, too low, that means we found a path, but it wasn't valid? Oh man. So we can print it out and try to see what's wrong with it. Alright, so let's get rid of all the H stuff. And we're not doing A star anymore, we're doing Dijkstra, which is just slightly simpler. So we said we'd skip a neighbor if we're hurt, we're dead, but they are still alive, because that means we're dead. Alright, take out H. Wait, why is it complaining here anyway? Oh yeah, because we took out H. Alright, did we... Yeah, we've taken out H. Okay. Huh. Okay, so we've taken the H out. Oh no, that's fine, that's fine. Actually, they only attack us if they have HP. So how did we ever get cases where... How did we get cases where we had negative, where we were dead? Because we never actually... did anything with our HP, did we? My HP, so if I do this here, if we're dead, that is not a state we want to put back into the queue. That makes sense. I mean, these numbers look okay. This is kind of what you'd expect, but something is wrong. Alright, we could actually test the example they've given. 914 is too low. Alright, so the example they had was ten hit points, 250 mana, and the boss has 13 hit points and 8 damage. So 10 hit points, 250 mana. Okay, let's try that. Example 1 equals so I have 10 hit points, 250 mana. The boss has 13. Try that one. 226. And in the example here, how much did we spend? We did poison, magic missile. So that was 173 and magic missile 53. So 226. Yes, that's correct. 226. All right. So it works for the example. Try the second example, where the boss has 14 hit points instead. Six, 4, 1. So in this case, we do recharge, shield, drain, poison. Magic missile, everything. We do one of everything. So it's 53 plus 73 plus 113 plus 173 plus 229. Six, 4, 1. That's what we got. So it works on the examples. Damn it. But it doesn't work on the state. Let's make sure we got the state correct. Start state. So we've got 50 HP. 500 mana points. Enemy has 55 hit points. Shield timers, poison timers, recharge timers is 0. Priority takes lowest priority, right? Yeah. Takes min. $914 is what we're claiming. We need to... Alright, so this is easier to debug, because we just have to now print what we're claiming is the set of moves, and we can verify by hand whether that actually arrives at 914. So how do we do that? We need to create a came from map. This is always okay. We have to do this. So came from. So whenever we find a new neighbor, we set came from neighbor state equals current. Then we put that in the queue. Item equals and then we return should we say less than or equal to? Maybe we've accidentally made their health go below 0. 914 still. No, that's not the issue. Okay. Alright, we'll just print that. But we return while we break. Stuck. Well, debugging it now. We've given a answer which is apparently too low, which means we've basically created a sequence of moves which probably does add up to 914, but apparently is not the best. It's better than the best. So we can that's good. That means we can actually look at it and see what went wrong. We can see what move is invalid. Because our answer is too low. So I just need to print out what moves we're doing. So when we exit out of this loop, we then have a came from. Actually, let's return. Hello, Sand Knight. Actually, we're doing a problem which is similar to the last one I was doing, but much more complex. And let me put the link. We're doing spells now instead of weapons and armor. And I've spent, oh man, it's almost 2 hours. I've spent 2 hours just coding part 1 and I still haven't really solved it yet. But I do have, okay, I have a sequence of moves. We're trying to check if that's actually valid now. Just trying to print it out. Right, so we go... Goal equals current. Path. We just want to print out the full path here. Path equals suffering. Not yet. I mean, I am pretty hopeful that it will. If we print out what moves it's showing us here, one of them will be wrong. That will. It has to be, because if the website is saying 914 is too low, that means we have a wrong move. So that's good. I would be worried if we had an answer that's too high. That means it's not optimized enough, and that's much harder to debug. Well, you can't debug it really. Well, you can't spot an error in it. So I just print path. Boss stats are the enemy has 55 HP and it does 8 damage. Are you sure skipping turns is allowed? No, I'm not, but it doesn't really say either way. The thing is, there are situations where you would have to skip a turn because you don't have mana. So I feel like it has to be allowed. Okay, maybe it does say somewhere. Let's have a look. Yeah, you know what? It does actually say, on each of your turns, you must select one of your spells to cast. If you cannot afford to cast any spell, you lose. It is a long problem description, so yeah, that's it. Thanks, Umara, you spotted the error. Okay, so that's easy to fix. You're not allowed to skip turns. That means if I get to a situation where I can't cast a spell, which is very easy to reach, because you cast a couple of spells, you're already out of mana, then well, that's already kind of handled. That means our neighbors will be empty, and we won't put any neighbors into the queue. So actually, we literally have to just delete the do nothing state. We don't have to check for having enough mana and stuff like that. So it's literally, it's that line there. Yeah, so you have to cast a spell. That's interesting, because that actually means you have a lot less choice now, which is good. Less branching. Because you have to do moves which are, you know, if your mana is low, you have to boost your mana. You can't just wait around doing nothing. Alright, so just take that out. Now run it. Wait. 953. Alright, I'll try that. Correct. Okay, so the program was pretty much correct all along. It was just the do nothing thing. Although I did have a invalid at one point I did have a bug. I was putting the heuristic into the queue instead of the distance. But yeah, nice. Now, before I go to part 2, out of interest, I might just want to finish what I was doing here and just print the path. It might be interesting to see. I guess it's also quite feasible to solve that by hand if you have a good instinct for what moves to do each turn. I mean, if Sandlight, you're interested in doing that, I can actually just you could try doing that while I'm doing part 2. Because I haven't actually printed what set of moves I'm doing. I'm just printing the best possible cost. Your idea seems to never drain. Okay, in that case, I will actually print the path. That'll be interesting. So, how do I do this? I've got to go to this level here. Path equals goal. Okay, so temp equals no. While power came from, so while the last element in our path still has something it came from, then we append wherever we came from. So this is now taking the goal and using our came from map to find our way back to the start. So we should end up at the start, and then we just return path, but let's put it back to front so that it goes forwards, starts from the start. Let's try that. Okay, let's stop printing loads of stuff. It doesn't look like we're going to reach Christmas Day today. Spent the whole stream on this one question. It's not, I wouldn't even call this hard. It's just very long to code it all, to account for the moves. But this is, you know, if you teach A* in a beginner's AI class, this is a standard problem you would give them. It would just take them probably 1 or 2 whole classes to actually write it all. Alright, so let's actually 4x in A*, print it line by line, otherwise we're not going to be able to read it. Yeah. Print x. Oops, what? No. Okay, so we start from the starting state. You have to interpret what they're doing here. So the first move, it looks like done a straight magic missile? Yeah, okay. Weird. I wouldn't have thought there could be an optimal path doing that. I guess it's because of the numbers of mana it lines up when you're... Alright. Okay, you've interpreted this. Okay, so it's poison. Yeah, because the poison timer goes up. And then recharge. Hello, Beef Viper. I did the first 6 days of 2015 last week with C++. Nice. Okay. So recharge, and then it's not a spell, is it? It's in your print, poison timer goes 5 to 3 because, and this was something I didn't realize at first, but on their turn, the timers go down as well, tick down. So shield actually activates on both your turn and their turn, but on your turn it's irrelevant, and on their turn it is relevant. But poison is relevant on both, and recharge is relevant on both. All right, Beef Viper. But yeah, I will continue with this until I beat Christmas Day. I was planning to do that today, but I'm not sure I'll have time now. Right, so okay, so what was it? It was magic missile, then poison, then recharge, then so we've done poison damage. It looks like it's another magic missile? Or so they've got poison damaging them for 6 damage total. And we've done another 4 damage, so it's another magic missile. And then poison. And then shield. Interesting, because you would have thought you should, if you're ever going to do shield, it might as well be as early as possible. But apparently there are optimal paths where you can do these out of order, and it's just happened to stumble onto them. So we've still got poison, so that means he's done another magic missile. And now we've done 7 damage to him, but there was only 1 poison happening. So we did 4, so it's another magic missile. And then finally, just magic missile, right? Because drain does change total you versus their health. Yeah. Yeah, it does look like it's useless. Yeah. Yeah, there's no. Is there any situation where? No. Because yeah. I could have just not coded it in. So that's an optimal path. There's probably other orders or sets of moves which can use that same amount of mana, but I guess it surprised me that magic missile gets used that heavily. I just instinctively I would have relied on poison, or at least I would have done poison first so that the poison is active while I'm doing magic missile. But I suppose because of the way these numbers work out, it doesn't actually matter in this case. But yeah. Yeah, so it's an interesting problem because it upgrades from what we were doing before, which was just try every possible starting point, but then the rest of the battle is fixed and predetermined from whatever you started from. So there's no element of search, just brute force trying all starting points. And we go from that to this, where we have a fixed starting point, but you have decisions to make along the way, which is technically more complex. And that's where you have to use a searching algorithm. And I've used... I should rename this to Dijkstra. Dijkstra. As a kid, I always called it Dijkstra. And then when I played Witcher 3, there's a character called Dijkstra. And I also had a Russian professor. And from him, I also learned it's called Dijkstra, not Dijkstra. I'm still trying to say Dijkstra. Okay. Part 2 then. Man, I'm gonna have a look at the forums that people posted after doing that problem. Like, I wonder if people spent as much time on it as I did, because it's long but easier than some problems in terms of mathematical ability needed, I would say. Okay. I like a nice short simple description here. On the next run through the game, you increase the difficulty to hard. At the start of each player turn, before any other effects apply, you lose 1 hit point. Well, it's easy to code, isn't it? If this brings you 2 or below 0 hit points, you lose. With the same starting stats for you and the boss, what is the least amount of mana you can spend and still win the fight? Okay. There's just one thing we need to make sure, and that's that we exit out immediately if we die from that 1 HP, because that could make the difference. So it's the get neighbors method. So on our turn, see, I wanted to write. Okay, we can still write this in a nice way. Just say hard equals false. So this will still work for part 1. As is. Okay, let's sort this out a bit. And then for part 2, we would do essentially this. So if hard is true, the only thing we need to change is in get neighbors at the start of our turn. Yeah, we can configure those, that's fine. Let's say, yeah, okay, right at the start, say, so it's, how does it work again? It's 1 HP at the start of each player turn. Oh, each player turn, not the player turn. So both us and the boss. Is that what they mean? Yeah, each player, okay. No. Hang on. This could be interpreted as being ambiguous, but I think when they bold player turn right there, they mean us, right? Not the enemy. Player being us, the player, and boss being boss turn. So they're saying only on our turn? Yeah, I think so, because they haven't given an example here, so... That's fine, that's easier to code. If hard... Whoops! What are you doing? Don't go to that. If hard... new state dot my HP. So even if we kill them, well, it's at the start of our turn, so we wouldn't have a chance. Well, wait, what happens if poison kills them and then it kills us? Well, we'll still die, won't we? I think we don't want to die. That's the priority. So minus equal 1. if my HP is, let's say, less than or equal to 0, we just return. There's no valid neighbor states here. That's it. So let's just run that. So it's now 1289. And this is. Alright, let's try the number first. I mean, this if part 1 worked, and if my logic here is correct, then there's should be no issue here. Correct. Okay. All right. Well, thanks for watching. That was one problem done in. It was about 2 hours 30, wasn't it? That was in line with how long it took me for last year's like live 2022. So definitely he started making them harder after 2015, but okay, as I said before, that wasn't hard, that was just long. All right, so I'll come back tomorrow, probably earlier than whenever I started today. Maybe I'll get all 3 done. All right, bye-bye.